starting Unit 3. We're going to talk about inequalities and their graphs. First, we're going to talk about the different inequality symbols and words that we use to represent them. So first off, in this box on the left-hand side, we have the symbol for less than. Words that we use to describe something that is less than include under, below, lower. Sometimes we see fewer than. When we add the equal sign underneath that symbol, it becomes less than or equal to. The big word that we see a lot of the times with less than or equal to is the maximum value. So something is at maximum 3 would make a less than or equal to sign. We sometimes see at most. We see no more than. So that means something that can be equal to a number or less than it, but not more. Next, when we flip the sign around, we call this greater than. Words we associate with greater than are above, higher, over, or more than, or a rarer one is exceeds. Then when we add the equal sign underneath it, it becomes greater than or equal to. And words we see associated with greater than or equal to, the main one is minimum. So something is at minimum 10, it means it can be 10 or more. It's a minimum value. It is at least, no less than, or no fewer than. So we're going to see these words a lot as we continue on with our problems here. We're going to be looking at word phrases and writing our own inequalities for them. If we do not already have a variable, we're going to go ahead and define that variable first. So in example 1a, it says the sum of t and 7 is less than -3. The sum of t and 7 should kind of remind us, hopefully, of what we did way back in Unit 1. The sum of t and 7 is t plus 7. That's what a sum is. That's going to go on one side of my inequality. On the other side, I'm going to put my -3. Then I'm going to look at the rest of the words in this phrase, and I see less than. Obviously, my less than symbol goes this way, and that is my inequality. T plus 7 is less than -3. In letter B, we don't have a variable here, so we're going to start by defining what our variable is. There are at least 10 players on the basketball team. So the thing that is in question here is P, the number of players. When I have a variable that I'm creating, I'm always going to try to put my variable on the left side. That goes for letter A too. I put that t plus 7 on the left side. It just makes my life a little bit easier. It's not the end of the world if it goes on the right side, but we prefer it on the left. So P, my number of players, will go on the left. My other number, 10, will go on the right. And then my word phrase says there are at least 10 players on the basketball team. At least means it could equal 10, but it could also be more than 10. So that is going to be greater than or equal to. All right, go ahead and try C and D. Pause the video and come back. All right, and for letter C, we have P is less than or equal to 4, where P is the number of pieces. And for letter D, X is greater than or equal to 10.99, where X is the price of a phone. Starts at is another one of our words that can mean greater than or equal to, so maybe we add that to our box as well. Often an overlooked part of inequalities is how to find their solutions. It's very simple. All we have to do to find the solution to an inequality is plug it in, and it is a solution if it makes the inequality true. So I'm going to go ahead and take this inequality, 13 minus 7y is less than or equal to 6, and I'm going to plug in my different values to see yes or no, is it a solution to the following inequality. So I start with letter A, -1, 13 minus 7. Anytime I plug something in, I'm plugging it in parentheses. And simplify this using GEMDAS. So -7 times -1 comes first to make positive 7, which is 20, is less than or equal to 6. And we know that that is a false statement, so this is not a solution. I can do the same thing in all of these other examples. So 13 minus 7 times 0, again, plugging it in parentheses. 13 minus 0, or 13. Again, not less than or equal to 6, so not a solution again. 13 minus 7 times 1 is less than or equal to 6. 13 minus 7 is less than or equal to 6, or 6 is less than or equal to 6. That is true. 6 is less than or equal to 6, so I would say 1 is a solution to this inequality. And lastly, same thing for 3. 13 minus 21 is less than or equal to 6, or -8 is less than or equal to 6. Again, that is true, so 3 is a solution to this inequality. The last thing that we're going to do is we're going to graph our inequalities on number lines. We graph inequalities on a number line to show all the possible solutions. Open and closed circles are used depending on the symbol. So let's talk about open or closed circles. An open circle is exactly what it looks like. It's open. And we use it anytime we are using the symbol greater than or less than. A closed circle is a filled-in circle. And we use a filled-in circle anytime we have greater than or equal to or less than or equal to. So I'm going to take a look here at letter A. X is greater than or equal to -4. I see this statement here in the directions. It says have at least 3 numbers labeled on the number line. That's going to be true throughout this unit. All of our number lines should have at least 3 numbers on them. So as I go through here, the very first thing I'm going to do is I'm going to take the number in my inequality and I'm going to put it smack in the middle of my graph. I'm going to pick a value greater than -4, and I'm going to pick a value less than -4. We know how number lines work. We have the positive numbers going to the right, the negative numbers going to the left. So if x is all the values greater than or equal to -4, I know that all the values that are going to make this equation true, they include the number -4. So I want to use a filled-in circle because of that equal sign. And I want to shade my graph or point my arrow to the right, towards all the numbers bigger than or more positive than -4. And that's my solution there. Letter B, I'm going to do the same exact thing. I'm going to take my number here, 2/3. I'm going to plop it in the middle of my graph. I'm not going to make things too hard on myself. I'm just going to pick a number that is bigger. A whole number works fine. And a number that is smaller, again, whole numbers work fine for me. This statement says h is less than 2/3. There is no equal sign, so I know it can't equal 2/3, so I'm going to use an open circle. And all the numbers that are less than 2/3 or more negative than 2/3 are going to go to the left. Now in letter C, I have 8 is greater than or equal to A. The only difference in this problem is that the variable is on the right-hand side here. I make my life a little bit easier by flipping this. When I flip an equation, I also have to make sure that the sign is facing the same way. So our sign is open towards the 8. The alligator Pac-Man mouth is facing the 8. So I want to make sure that it is still facing the 8 when I flip my inequality around. 8 goes in the middle. I pick a number higher and a number lower. I have that equal sign, so I know 8 is going to be included in my solution, so I'm going to fill that in. And then all the numbers less than or equal to 8 means my arrow points to the left to indicate all the numbers smaller than 8. Go ahead and pause the video and try D, E, and F. All right, here are my solutions to D, E, and F. Now we're going to go ahead and work backwards. I'm going to start with the graph, and I need to write the inequality for each one of these. First things first, I'm going to look at where the circle is on my graph. I'm going to use a variable. I just always pick the variable x. And then my circle for letter A looks like it lies on -3, so -3 is going to be on the other side of my inequality. Now, the difficult part is figuring out what inequality symbol goes in here. I see that this circle is open, not filled in, so I know that I'm not going to have an equal sign. And it's pointing to the left, which are all the numbers that are smaller than -3, which means x is smaller than -3, aka less than -3. I'm going to repeat the process for B. I start with x. My bubble is on the number 0. And then I look at that bubble to figure out which way my sign points and whether it's filled in. Filled in circle means I am going to have the equal sign. It's pointing towards all the numbers bigger than 0, so x is greater than or equal to 0. Same thing in letter C. X and -1. I have a filled in circle and pointing towards all the numbers greater than -1, so x is greater than or equal to -1. And finally, letter D, x and 4, open circle, pointing to the left, all the numbers smaller than 4, so x is less than 4.